function. Now we're going to move it to the left 5. So easy. Take every point that you've already plotted, and we're just going to move it 5 to the left. Now you can either do point by point, or once you move it over, you know that it just follows the parent function pattern. So you can count out and down if you want. So you now have an upside down parabola who's been moved to the left 5 units. The last thing you have to do is now take that parabola and then just move it down 2. So again, nothing too tricky on this first one. You're just mostly making sure that you can identify the transformations. Okay, that's really the key for today. Okay, so when you're done with that one, you should get a parabola that looks like the last one. Now, if you decided that you can do all this in one step, that's totally fine. Just make one graph. It should look like the last step here. But you would still have to at least write out all 3 steps. We okay so far? It's coming back after a day off. You're going to retire? Well, you need at least 1 more math credit, and then you can retire. You need 4 to graduate high school. Through Algebra 2, but 4 credits. How did they decide that? It's the state's rule. I don't know. Or English is more. It's just what the state told us to do. English needs 4, history needs 3, science needs 3, math needs 4. Yep. All right, next one. This is what we did on Tuesday. What does the 1/2 out in front do to your parabola? It does a what? It does something to the y. So it's called a vertical compression. So I'm going to abbreviate that, but this is a vertical compression. And I'll just write by 1/2. So by a factor of 2. But we're going to make our graph a little bit shorter. By half. What does the negative inside the parentheses do? Yep, so that's on your quiz today, knowing that that means reflect over the y-axis. And the -4, down 4. All right, so the first one, when I vertically compress by a half, does that change the x's or the y values? That's what I was going to ask. Where? Down 4, sorry. I don't know if that looks more like 4 or not. Alright, when I vertically compress by a half, that changes the y values. The y values are half as tall. So my origin stays the same because the y value at the vertex here is 0. But when I go out 1, my parent function, I'm at the point 1, 1 here. What's half of the 1 for the y? A half. So it's going to be a 1, 1/2 on either side. Okay, so you're just going half as tall. Instead of 2, 4, I'll be at 2, 2. Good. And instead of 3, 9, half of 9 is 4.5. And if you wanted, we could fit another point on there. We would go out 4, 16. What's half of the y 16? 4, 8. So we'll be at 4, 8 here.
You know that, man.
I did. Yes, what's your question?
Are the compressions and stretches, are those on the quiz?
That'll be on your quiz tomorrow. So quiz today is just reflecting. The stretches and compression will be tomorrow. But we'll get more practice today. Good, so we compressed it. Now, here's the question. When I reflect this graph over the y-axis, does it make it look any different?
No.
Why not?
Symmetrical.
Yeah, it's symmetric, and this graph's axis of symmetry right now is the y-axis. So if I flip it over the y-axis, it's going to look the same. So if you want, I'm just going to draw an arrow. I'm going to skip to the next one, because it's going to look exactly the same when I reflect this one over the y. Good? All right, now all I have to do is move this graph down 4. So your vertex will be at 0, -4 now. And the same pattern, out 1, up a half. You can move each ordered pair at one time, if you want to. There you go. And you should get a nice, a little wider looking parabola.
Oh my God.
That's down.
That's what you're supposed to do.
You're fine.
I needed to snow a spot that harder.
What'd you say?
That I needed to snow a tad bit harder.
We're only supposed to get about an inch today.
Oh my goodness gracious.
I love the snow. Winter is my favorite.
Why?
It's just so,
Even though you're a gardener?
Oh.
what?
That's
You like
funny.
to garden?
Well, I mean, I like to garden and
Yeah,
stuff,
what
but
about your
snow is so
garden?
pretty.
I
My
got-
garden's under snow right now.
It's straight up white. I don't.
All my tomato things are under snow.
You
All
make
right.
your own salads.
What?
You make your own salads.
Yes, so I had 18 tomato plants last summer
Okay.
and cucumber,
What
3
kind?
all kinds of varieties,
Oh,
different colors.
really?
I just buy them based on their name and what they look like. So like Mrs. Krause and I both grow a ton of tomatoes, and we just will like compare. We both go to the store together and like, oh, this is a cool name, so we'll get that one. Then I grew some tomatoes, I had a bunch of different herbs, 2 kinds of lettuce, 2 kinds of peppers, a couple cucumbers.
Did you eat them? Like,
I did, and then I made pasta sauce. So I had 42 pounds of tomatoes that I saved, and then I had canned pasta.
Did it taste garlicky?
No, I mean there's garlic in there, but it didn't taste garlicky. I had some last night.
How do you get so many tomatoes? Because when I go to my house, we get like 5.
I don't know. It's because I have 18 plants of them, not just one. I grow 18 tomato plants.
Wait, the little ones or the big ones?
I do some of both. So the little ones I just eat. I don't can with those. I just
The little ones, the best kind are the
Oh
Sweet Sugar 100.
really, I like the bumblebee.
I don't know what that
They
is.
like have stripes on them, but I get so many of them. Like I'll bring them in to like other teachers. Yeah, the bumblebee tomatoes are my favorite tomatoes. They're cute. They're like pink and yellow. All right, we'll get back on track here. Negative 2x squared plus 5. What does the negative out in front do to your graph?
Over X.
Reflect over the x. So again, we're going to flip our graph upside down. Okay. What about the 2? What does that do to your graph? This was new the other day as well.
Vertical stretch.
A vertical stretch. So because the 2 is greater than 1, the absolute value of it, we're going to vertically stretch our graph by 2. It's going to get longer. And then plus 5? Up 5. Okay. Now, reflecting over the x-axis, we've done that a lot of times now, so that's an easy graph to start with. You just turn your parent function upside down. So I'll give you a second here to plot those points. Now, if I'm vertically stretching something, does that change the x or the y's? The y. So now the y's this time, you're going to take the y value and multiply it by 2. So my origin or my vertex stays at the origin. However, instead of being at 1, negative 1, where my point be? 1, negative 2. So it should be down 2 this time. Instead of 2, negative 4, I'll be at 2, negative 8. And that's really all that's going to fit on your grid there. So you should have a nice, skinnier looking parabola.
I'm really confused about how you got that, but
Which part? The reflected or the vertical stretch? So I changed the y coordinates. So when I look at this point right here, is 1, negative 1. I'm only changing the y value of negative 1. I multiply it by 2. Negative 1 times 2 is? What? I can't hear you. Well, negative 2. Yeah, I changed this one. I multiplied this y value by 2, which is at negative 2, which is why I plot that. The x stays the same. We're not changing the x till tomorrow. Now this point is at 2, negative 4. I only change the y value. I multiply it by 2, and negative 4 times 2 is negative 8, which is why you're down there. Does that make sense?
Yeah.
Yeah? Now you're going to move that graph up 5 if you haven't already. And let's see. Go. Good. So we should have this parabola right here. And again, some of you could do all that in one step. That's totally fine. Are we okay so far? Yes? Okay, one more, and then we'll switch it up a little bit, but we're almost done with the notes here. I have 3 times x minus 4 squared plus 1. So what does this 3 do to your parabola? The vertical stretch. All right, 3 is greater than 1, so that means it's vertically stretching our graph by 3, so it's going to be even skinnier than the last graph. What does the minus 4 in the parentheses do? Right 4 and up 1. Okay, now when I vertically stretch, remember that only changes the y value. So instead of being at 1, 1 here, I multiply the y by 3, which would be 1, 3. So we got 1, 3 on either side. My next point, instead of being at 2, 4, I multiply the 4 by 3, which is 12. So you get 2, 12, which is off your grid up here. Okay, so there's actually only 3 points of this graph that are going to fit on the grid. Once you stretch it, it's easy to move it to the right. You just take all of those points to the right, 4 units. Try to put a couple up there. And then again, moving it up 1 is not a hard one to do either. Start at 4, 1. So we're not going to have a quiz just on this graphing stuff, but you need to understand how do you graph all the transformations. So we just went step by step today. You need to understand what all the numbers and signs do to the equations. That's really what this is, putting everything together. So let's try on the bottom. This time I'm not giving you the equation. We need to write the equation. So I'm giving you the parent function, though. The parent function is the graph that's here at the origin. That's the parent function. So what do you notice about the second graph? What has happened to us? It went down how many? Down 4. Okay, that's one transformation. We went down 4. What else happened to our graph? Left 3. All right, does it look like my graph stretched or compressed? No, because if you can't, remember our trick was if I go out 1 and up 1, that's a regular parent function pattern, so it didn't stretch. So we're going to write our equation, y equals. Now you did this on your quiz the other day, so this should be, this one not too bad. What goes inside, the left or the down? The left. How do I write left 3? Plus 3. Now don't forget your squared. Some of us lost our squared in our equation. And then down 4 would be minus 4. If I look at number 6 here, I start with my parent function. What do you notice about this other graph? Okay, so it reflected over the x. All right, someone said a stretch, right? Vertical stretch. How much did it vertically stretch by? 2. I go out 1, down 2. So I have a vertical stretch by 2. What else happened? Up 3. Running out of room. Right 4.
That's a lot of work.
Kind of all over the place. Yeah, so a lot happened in this equation. So we're going to take one thing at a time. Of those 4 transformations, which one has to go first in your equation? The reflection. How do I do that? Minus. Which one has to come next? The vertical stretch. So negative 2. Then I can do my parentheses. I do the right, which would be x minus 4 squared plus 3. And that's your equation.
That's fine.
One more. That's it. Just one. Last one here. What do you notice about it?
It's
wider.
widened.
It's wider, so there's a vertical compression. How much is it vertically compressed by?
1/2.
1/2. Yeah, because you can't tell from the first point, but if you go out 2 instead of up 4, it only went up 4. Or up 2, I'm sorry. So it's vertically compressed by 1/2. It's half as tall.
Left 5.
Left 5.
Down.
Yes. Right. So we'll write our equation. Y equals. Which has to come first? The 1/2. Okay. And inside your parentheses will be x plus 5 down 2. Alright, not too bad. Now, one other thing I'm going to have you do is a little bit of the practice. So I think I'm going to make you work on the practice for at least like 10 minutes here. So then I can give you your quiz at the very end. So there's some practice. I want you to do that because there's reflections on the practice, there's vertical stretch compression on the practice. A few minutes, at least be able to write the equation, identify what's going on, right? Equations. We'll go through those first, so about 8-9 minutes here. Then we will take our quiz for today, okay? And some of you